Now, you've just recently received back your results for your volumetric analysis test, and I'm going to go through the solutions with you now, because there's a little bit of confusion for some of you in relation to percentage WV and how to use that in terms of concentration and so on. So I'm just going to go through the questions very quickly and then put this video up in the classwork section, and I would ask you to work through them, listen to me and work through the solutions so that you understand where your errors were made along the way. So question 1 says, hydrochloric acid is severely corrosive to the skin and eyes and toxic by inhalation or ingestion. It should be handled carefully and stored safely. The entire contents of a bottle containing 4.5 litres. Now, one of the things I would ask you to do is just to highlight or to circle things that are of interest and may be used in your calculations later on. Where accidentally spilled. The spilled acid was neutralised by adding solid powdered sodium carbonate, and then the reaction is described by the following equation. Now look, if you go back over the videos we were looking at and the lessons that I gave you there recently, you would have seen that one of the actual focus of attention was the reaction between a liquid and a solid. Okay, and if we're reacting a liquid with a solid, the one medium we always have to move through is moles. In fact, for every chemical calculation, the very first port of call should be moles. Okay, so I have one thing to work on so far, and that is that the bottle contains 4.5 litres of concentrated HCl. Now, they give you a balanced equation, which is extremely important in terms of knowing the ratio of reaction. Here, it's 1:2, and we will be using that later on. The spilled acid was a 42% WV solution of hydrogen chloride in water. Now, what's 42% WV? 42% WV means weight in volume, and the 42% means 42 grams in 100 centimeters cubed. Okay, now two things here. First of all, percentage WV is a very medical way to write concentration. It's not what we use in chemistry at this level for Leaving Cert. We have to use only one standard measurement, moles per litre. So if they give you percentage WV, your job is to change the 42 grams into moles and the 100 centimeters cubed into litres. So let's do that. What are we dealing with? We're dealing with a solution of hydrogen chloride in water. Now, hydrogen chloride, as we know, is H and Cl. H has a mass of 1, chlorine has a mass of 35.5, so therefore the total molecular mass of hydrogen chloride is 36.5 grams. So I'm going to turn this into moles by dividing by 36.5 and see what I have at least in the 100 centimeters cubed. So 42 divided by 36.5 works out as 1.15. So I have 1.15 moles in 100 centimeters cubed. But the standard volume in chemistry is a litre. So I now have to multiply this by 10 in order to get it up to 1 litre. And I'm going to do exactly the same thing on this side, multiply by 10, which is 11.5 moles in 1 litre. Now that's extremely important going forward, because first of all, that's the molarity. That is the concentration in moles per litre. How many litres did we take? Or in this case, how many litres did we spill? Well, go back to the top of the question. We spilled 4.5 litres. So in other words, how many moles did I spill? So we just multiply that by 4.5. So 11.5 by 4.5 comes out as 51.75 moles of HCl spilled. Okay, so you notice how I'm working with moles all the time. It's the center of the chemist's universe. It is our sun. Okay, for want of a better phrase, we have to use it. Okay, so 51.75 moles of HCl spilled, and that's the first part for 10 marks. Now, part 2. What was the minimum mass of anhydrous sodium carbonate required to completely neutralize all of the spilled hydrochloric acid? Now that is looking at the relationship, the reaction, or the ratio between sodium carbonate and hydrochloric acid. Go back here. We have a ratio of reaction. The ratio of reaction between the acid and the sodium carbonate is 2:1. So therefore, we only need half the number of moles of sodium carbonate to neutralize this thing. So I'm going to divide it by 2 to work out the number of moles of sodium carbonate. Now, when I divide by 2, I get 25.8 0.75 moles of sodium carbonate, Na2CO3. Okay, and again, I'm working in moles all the way. They want you now to turn that moles into mass, most important thing. So to go from moles to mass, I'm going to multiply by the mass of sodium carbonate, Na2CO3, which is 23 and 23, which is the two Nas, and then you've got 12 for the carbon, and then you've got 48. So when you add those up, you get 106. So I'm going to multiply that by 106. By the way, 106 is the molar mass of Na2CO3. It's how heavy 1 mole is in grams. So we multiply that by 106, and we work out that we need quite an amount of this stuff. We need 2,742.75 grams, or if you want to, 2.74275 kilograms. But it didn't ask you for the change, so that's perfectly fine. And that was given you for 9 marks. And then finally, what volume of carbon dioxide in litres at room temperature? So now we're looking at CO2, okay? At room temperature and pressure was produced in a neutralization reaction. So go back to the reaction. Now ask yourself, what's the relationship between sodium carbonate and CO2? And the answer is 1 is to 1. So therefore, the number of moles of sodium carbonate is going to be the same as the number of moles of carbon dioxide. So CO2 to Na2CO3 is 1 is to 1. Meaning what? Well, if I needed 25.875 moles of sodium carbonate, then I'm going to have 25.875 moles of CO2. And they want you to turn it into volume. Now, I made a little slight mistake here. I meant to tell you what the molar volume is at room temperature. It's 24 litres. Okay, that will be printed on your paper. I forgot to put it in there, so I am accepting the 22.4 if you use it as well, because that was my mistake completely. So let's just multiply it first by the 22.4 if it was asking you for this thing at STP. So get that 25.875 multiplied by 22.4, and we would get, in the first instance, 579.6 litres. Now, if you copped on to the fact that it was room temperature and you remembered it was room temperature, well then instead you would multiply it by 24, okay? And you would end up getting, let me just see now, you would end up getting 621 litres. So look, I accepted both of those answers because I didn't tell you what the actual molar volume was at room temperature, and I should have, because it will be on your chemistry paper. Okay, and 6 marks for that. So again, it's all about stoichiometry. It goes back to that chapter in stoichiometry when we're doing all the calculations based on the number of moles of one substance. And once you work out the number of moles of one substance, you have the rest. Question 2. Name the pieces of equipment A, B, C shown below. Look at the first one. There's a tap. Okay, and the only glassware with a tap is a burette. Okay, this thing here, deionized water or wash bottle. It didn't ask you what was inside. It asked you what's the equipment. Be very careful. They'll hammer you in the exam. I won't. I'm nice. The chemistry exam will hammer you. If you put down deionized water, nothing. Because they didn't ask you what was in it. They said name the piece of equipment. That is a wash bottle. Okay, now I know it contains deionized water. So look, first time round I'll give you the marks. Not again. Be careful. Read the question carefully. And then conical flask. So you got 3 marks for each of those, giving you a total of 9. And finally then, we have a titration. Okay, now when you hear the word titration, or in this case, when you are comparing a solution to a solution, we always use the formula V1M1 equals V2M2. Always. Okay, so make sure V2M2. So always make sure that when you know what you're comparing, if it's a solution to a solution, as it will be always in a titration, then V1M1 equals V2M2. And notice, what's the rate of reaction? 1 is to 1. So therefore I don't need to divide either side by anything. I just keep it as V1M1 and V2M2. Okay, let's read on. It was found that 25 centimeters cubed of the sodium hydroxide. Okay, so first of all, let's write these things down. Where HCl is being titrated with NaOH in a ratio of 1 is to 1. So let's put down our V1, our M1, our V2, and our M2. So what did it tell me? 25 is the volume of sodium hydroxide. 22.5 is the volume of HCl. 0.1 molar is the concentration of HCl. So what do I have straight away? No molarity of sodium hydroxide, because guess what? That's what they're asking me to find. Okay, so all I've got to do here is multiply these two together. So it's 22.5 multiplied by 0.1 is equal to 25 times x, which means x is equal to 22.5 multiplied by 0.1 divided by 25, okay? And that comes out as 0.09 molar. That's the molarity of the NaOH, or if you want to, 0.09 moles per litre. Same symbol, exactly the same meaning. And the last thing they asked me to do then is to turn it into grams per litre. Well, if I know what it is in moles per litre and I want to go to grams per litre, I go from moles to grams through multiplication. And I multiply by the mass of the substance we're talking about, sodium hydroxide, NaOH. Na, 23, oxygen, 16, hydrogen, 1. What's that? 40. So you're going to multiply that by 40 and you get 3.6 grams per litre as asked. Okay, now I was kind of generous with the moles per litre. I gave 9 marks for moles per litre and only 3 then to multiply it out into grams per litre. So that's the first test we have in volumetric analysis. Now you're moving into practicals, virtual practicals this week, so there will be another test once the practicals are done. Hopefully we'll get 2 practicals done before the midterm break, we'll get another 2 practicals done after the midterm break, and then we'll have a test just on practical work. Okay, so go over the solutions, make sure you understand where you've made any errors, and if anything is unclear or you need further help with any part of that test, just send me an email.